Good morning, students. Today, let us see computational thinking, right? I am Dr. A.K. Jaithunbi, Associate Professor from the Department of Computer Science and Engineering, RMD Engineering College. Let us see the four definitions of computational thinking. In 2014, Wing gave the definition as computation thinking is a thought processes involved in formulating a problem and expressing its solution in such a way that a computer, human, or machine can effectively carry out. Right? Yadav et al. He gave the definition as the mental activity for abstracting problems and formulating solutions that can be automated. Later, Ferber defined computation thinking as the process of recognizing aspects of computation in the world that surrounds us and applying tools and techniques from computer science to understand and reason about both natural and artificial systems and processes. By Hemmingdinger, right? Computational thinking is a teaching, that is, how to think like an economist, a physicist, an artist, and to understand how to use computation to solve their problems, to create and to discover new questions that can fruitfully be explored. Right? So, these are the four definitions. Right? Finally, Denning he gave an elaborate view of computational thinking, which is related to our project and to the latest application oriented concept. It is a mental orientation to formulating problems as conversions of some input to an output and looking for algorithms to perform the conversions. Today, the term has been expanded to include thinking with many levels of abstractions, use of mathematics to develop algorithms, and examining how well a solution scales across different sizes of problems. So, the major core concept of computation thinking is logical thinking, algorithmic thinking, decomposition, generalization, and pattern recognition, modeling, abstraction, and evaluation. The other peripheral concepts which are related to computation thinking are data representation, critical thinking, computer science, automation, simulation, and visualization. So, the list of examples for a computation thinking is, suppose if you give a project to the student to make the graduation ceremony a grand success, right? So that it's like a computation thinking, right? And the second one is predicting the climate change. Third one is sorting music charts. And the last one is the case which is handled by police, lawyers, and judges and how to assist them. Now, we all know that any problem in this world has n number of solutions, right? Always we prefer the best one and the optimized one. So, there are some problems, right, that we'll face in computation thinking, and certain things may disappear as you start solving the problem, right? That is, once you get experience, right, practice makes one perfect. So, certain things like maturity, efficacy, and perceived imperialism will disappear as the computation thinking matures. Now, computation thinking is not computer science. Okay? Computation thinking is an approach to problem solving. It assumes a computer will execute the eventual solution. Thus, computation thinking teaches an approach to problem solving where the ultimate aim is to provide a solution whose form means it is ready to be programmed into a computer. Computation thinking takes a relatively small subset of concepts which just happens to be important to CS and uses them to construct a widely applicable problem solving approach. Finally, computation thinking is an approach to problem solving that involves using a set of practices and principles from computer science and to formulate a solution that is executable by a computer. It is not just for programmers, in fact, it is applicable in a diverse area of fields. Thank you, students.